Hi everybody. This video is about simplifying the square root of a monomial using factors. Now, dealing with factors is a really important arithmetic skill, but it is something that takes a bit of practice. I'm going to show you two ways to do this. Normally I don't like to show multiple ways to do something, but in this case it's very necessary. So the first thing we have to do before we really get started is we have to find all of the factors of 72. So if necessary, go to a piece of scratch paper and make a factor tree, or otherwise in some way factor the number 72. Well, 72 is 8 times 9, and 8, I'm going to cheat here and do 3 branches. 8 is 2 times 2 times 2. 9 is 3 times 3. So if I want to break this all the way down to prime factors, 72 is 2 times 2 times 2 times 3 times 3. So what we're going to do is, using the first method, is we're going to rewrite the square root of this monomial as the square root of all of its factors. So we have 2 times 2 times 2 times 3 times 3. And now, just for emphasis, I'm going to do the same thing with all of the variables. We have u times u times u times v times v times v times v. Once you get comfortable with this, you don't really have to write all of the factors. You'll do a lot of this in your head once you see what's happening. So here's the logic of how to simplify the square root. You look for a pair of the same thing underneath the square root. And in your head you say something like this: well, I know that 2 times 2 is 4, but then when I take the square root of 4, I get back to 2. So if I have a pair, 3 times 3 is some number. Now we know that it's 9, but it's actually not important. 3 times 3 is some number, and when I take the square root of that number, I get back to 3. And the same logic works with the variables. If I have a pair, u times u is u squared, I take the square root, I get back to u. So anytime you have a pair, I don't want to underline 4 times, I'm going to switch colors to green. So we have this pair of v's and another pair of v's. So 2 times 2 is some number. Again, it's 4, but that doesn't matter. When I take the square root, I get back to 2. 3 times 3 is some number, and when I take the square root, I get back to 3. So if I have any pair underneath the square root, it looks like it comes outside of the square root as just a single thing. So I'm going to take out a u, a v, and another v. Now underneath the square root, I'm left with everything that I didn't underline. So we have a 2, a u, and that's it. So we have a 2 and a u. Now let's just multiply everything together that we can. So outside I have 2 times 3 is 6, I have a u, I have 2 copies of v, so v times v is v squared, and then still underneath the square root I have 2u. There's nothing I can do here. So this is how you simplify radicals, simplify square roots, at least at the beginning. Now you might think that this is a rather involved process, and I guess it kind of is. However, once you get comfortable, there's lots of ways you can speed this up. So let me show you a really fast way to do it. Now, be warned, you probably won't be able to do this when you're new to simplifying square roots, but once you have some practice, here's how you could speed it up. Perhaps you notice that 72 is 36 times 2. And rather than writing out all of the variables in expanded form, I'm just going to leave them as exponents. U cubed v to the 4th. And here, I know that the square root of 36 is 6. If I have 3 copies of u and I can take out pairs, then that means I can take 1 u out. If I have 2 pairs here, because 2 pairs makes 4, I can take out 2 v's. And then I'm left with this 2. And then if I look at this odd number of u's, considering that I take out in pairs, I'm left with 1. Now, the obvious problem with this method is, well, I noticed that 72 had 36 as a factor and 36 is a perfect square, so I could take the square root. If you don't notice that, then you're kind of forced to work all the way down with prime factors. So what you'll do in reality is, with relatively small numbers, you'll do it like I did here on the right, and you'll look for perfect squares. But if the number gets too large, or you have some awkward factors that you typically don't memorize with your multiplication tables, then you'll go down to prime factors. So both of these methods really are necessary, and it just takes some practice, and in reality you'll use a combination of both of them. Anyway, hope this helped.